Okay, welcome back to chemistry. So I wanted to go through a couple of examples of using the mole and doing conversions. So getting from grams to moles, moles to grams, but then also to get to numbers of things. So these are the two things that we're going to do. The concepts that we're going to have, right? So if I start with grams and I want to get to the number of moles of something, right, which is my number of stuff, right, that I have to use the molecular weight. Right, this is what comes from the periodic table, right? And vice versa, right? So if I'm doing a conversion that involves grams to moles or moles to grams, I need to know the molecular weight, and I'll look that up in the periodic table or add it together. If I want to get to numbers of things, right, I can only do that going from moles to numbers of things. And when I do that, I'm always going to use Avogadro's number, which is 6.022 times 10 to the 23rd. Right? And so the key thing is we'll have a conversion factor for each of these. Every one of these is going to have a different conversion factor, right? So if I have a different substance, I'm going to have a different conversion factor. Here, my conversion factor is always going to be the same. If I have 1 mole of something, doesn't matter whatever it is, that's going to be the same as 6.022 times 10 to the 23rd of that thing, right? Whatever that is. Right? So if I have, I don't know, a mole of pens, then I'm going to have this many pens. If I have a mole of paper, I'm going to have this much paper. If I have a mole of carbon atoms, I'm going to have this number of carbon atoms. If I have a mole of, I don't know, methane molecules, I'm going to have this many methane molecules. So these are the two things that we're going to have. And so the only thing get the complexity that I'm going to add in here is that if I want to go from grams to numbers of things, I've got to do 2 calculations. Or if I want to go from numbers to grams, I've got to do 2 calculations. This is the primary one. So going from grams to moles and moles to grams, that's the primary one that we're going to do a whole bunch in chemistry. Really important to get this down. Let me go through a couple of examples. Suppose I had, 16.2 grams of carbon, and I wanted to figure out how many moles of carbon that is. Well, here I am. So I'm going to be going from grams to moles. So I'm going to need to figure out the molecular weight. And I'm going to get this from the periodic table. So let me pull up periodic table. ptable.com works really well for this. We'll look at carbon. There it is. Carbon has this number 12.011. So this tells me, I'm going to be careful how I write this down. So this is going to tell me that, and this is my conversion factor, I have 12.01. That means if I have that many grams of carbon, that's 1 mole of carbon. Now remember, I can write this as 2 fractions, right? I could fractionate it as 1 mole of carbon on top and 12.01 grams of carbon on the bottom, or I could write it the opposite way and have my 12.01 grams of carbon on the top and 1 mole on the bottom. Right? And I have to choose which one of these is going to be useful. So I'm going to start my conversion factor. So here we go. This is what I was given, so that's where I'm going to start. So this is what starts in my crosshairs. I have this many grams of carbon. And I want to figure out which one of these 2, so you may recall the only thing I need to care about is this unit. So I'm going to look for this unit, and I need that unit to show up down here, which means this is the thing that I want to use. Right? So when I do that, I'm going to put my 12.01 grams of carbon and my 1 mole of carbon. And as you saw from the simulation that we did last week, these are going to cancel. And now I'm going to do math. I'm going to 16.2. I'm going to divide that by 12.01, and what did I get? 1.35? Sure, 1.35, and I'm left with this unit of moles of carbon. All right. So this is using just the numbers from the periodic table. So we'll make it a little bit more complex. So suppose instead of having 16.2 grams of carbon, I had 16.2 grams of carbon dioxide. So now I have 16.2 grams of CO2. And I want to figure out how many moles that is. Well, now I need a different conversion factor. So my conversion factor is going to include carbon, and I just looked that up. It has a mass of 12.01. I'm going to need oxygen as well. So I'm going to go to the periodic table and look up oxygen and discover that it's 16.00. But I have 2 of these and 1 of these, right? So this is finding the molecular weight for a compound. I'm going to add these together. I have 12.01 and 32 coming from this, and I end up with 44.01. This is a number, but I need to put some units on it to make sense out of it. So I have 44.01 grams of this stuff is equal to 1 mole of this stuff. Right? So every time I do one of these gram to mole conversions, I'm going to have a different conversion factor that I have to figure out. And this is the challenge with it. The conversion factor you get to from the periodic table, but it's going to be different for every compound that you use. And now my math is going to be the same. I'm going to start with what they gave me. They gave me 16.2 grams of carbon dioxide. I want to decide which of these two is going to go on the bottom, and I put the other one on the top. Right? So I have grams of CO2 here, and I'm going to want grams of CO2 showing up down here. So I'm going to stick this on the bottom, and this is going to go on the top. Right? So when I do that, I end up having 44.01 grams of carbon dioxide and 1 mole of carbon dioxide on the top. And when I do the math, what do I get? I get 0.368, 0.368 moles of CO2. So notice that there's a big difference, right? So carbon dioxide is a much bigger molecule, so it has more mass. So even though I have the same number of grams that I started with, I'm going to have fewer of those things, right? So it's just like, I have a container that has has a kilogram in there, and I can get a larger number of jelly beans in there than I can of tennis balls. Right? So I have something bigger, there's just going to be a smaller number of those things. So let's do the reverse, right? So we can go from grams to moles, but we're also going to ask you to go from moles to grams, and this is really important for chemistry because we waste stuff in the lab. Let's see. Let's start with a different one. So I'm going to start with 5.40 moles of carbon. I'm going to look up on the periodic table and discover 12.01 grams of carbon is the same as 1 mole of carbon. This is my conversion factor. I'm going to start with what they gave me, so I'm going to start with 5.40 moles of carbon. So notice now I've got to arrange things a little bit differently. So what do I have? I have moles of carbon on the top. I don't want my moles of carbon to be on the bottom. So this thing's going to go here, and this thing is going to go on top. So I'm going to end up having 1 mole of carbon on the bottom and 12.01 grams of carbon on the top. And now I get out my calculator and I do math. What do I get? Like 64.8 and 64.8 grams of carbon, right? So this cancels and I'm left with my grams of carbon. Well, let's do the same thing for carbon dioxide, right? So if I have 5.40 moles of carbon dioxide, well, any predictions? Well, carbon dioxide is going to be heavier, so I have the same number of these two things. I'm thinking this carbon dioxide should be heavier, should be more than it was for just carbon. Well, let's see how it comes out. So I'm going to recall the conversion factor that I had for carbon dioxide. Carbon dioxide was, what did I come with, 44.01 grams of carbon dioxide is going to be equal to 1 mole of carbon dioxide. And now I want to arrange my crosshairs, so I'm going to have 5.40 moles of carbon dioxide. That's what he gave me, so I want to start with that in my crosshairs. I want to arrange so that my units cancel, right? So now the units I care about are moles of carbon dioxide. I want this to go down here and this to go on top. So now when I put my moles of carbon dioxide on the bottom, they will cancel, and I'll be left with something that I can calculate and give me the unit that I want it to get to. I plug this in, what did I get? I got 238 grams of carbon dioxide. So yeah, so it's a lot more, right? So it's almost 4 times as much, right? So the mass was almost 4 times as much, and if I have the same number of those things, they weigh 4 times as much, right? So this is what we do in the lab, right? In the lab we can weigh grams, so we're weighing different amounts of grams of stuff, but we need to figure out the different numbers that are there. Okay, last thing that we do, right? So this is where we started, that we can get from grams to moles and moles to grams. The second thing is sometimes we want to get to numbers of things, right? So for these conversions, we're always using molecular weight, and it's always going to be different, sadly. But when we're getting from moles to numbers of things, that's always the same conversion factor. That's going to be this one, right? So if I had, what is it? We're going to end up with 1.35. Let's do this. So if I end up with 1.35 moles of carbon, how many of those things in that? In this case, this is atoms of carbon. And then secondarily, we calculated that we had, okay. Secondly, if I had 0.368 moles of carbon dioxide, how many of these things, but now I don't have atoms, this is now a molecule. So I'm going to say this is the number of molecules of carbon dioxide. So I'm going to do the same conversion, right? So I'm going to start with what they gave me in both of these cases. In this case, I have 1.35 moles of carbon, and going from moles to numbers of things, it's always the same, right? So I know this conversion, 1 mole is equal to 6.02 times 10 to the 23 of those things. So I'm going to worry about having the mole on the bottom. In this case, 1 mole of carbon is going to be equal to 6.02. Well, I have to throw another digit there, 2 times 10 to the 23. Of those things, carbon atoms. Right? And now I get my calculator out and I can do math. And so in the second one, I can also do this, 0.368 moles of CO2. I'll draw some crosshairs. Again, I'm going from moles to numbers of things, so I know 1 mole of anything, including carbon dioxide, is going to be this number of those things. But these things now are molecules of carbon dioxide. Now we get my calculator out. Let's see what we get. So 1.35 times 6.022 exponent 23. So I got 8.13 times 10 to the 23 atoms of carbon. And this one, 68 times 6.022 dx 23. I'm going to get 2.22 molecules of carbon dioxide. Oops, times 10 to the 23 molecules of carbon dioxide. Right? So notice what we did. So this 1.35 moles I took from our first problem. Right? So I took 16.2 grams. We figured out how many moles that was. And then I took those 1.35 moles and we figured out how many atoms that was. So we can do this in 2 steps. And this is sometimes where we want to or we need to know the number of things. And I can do this in 2 separate steps. But notice that I have to use 2 separate conversion factors. So I can get from grams to moles to numbers of things, and that's going to be different. So the easiest thing, right? So moles is essential. If I know moles, then I can figure out grams, or I can figure out numbers of things in 1 step. Anyway, I hope this is helpful to see a couple of examples. And if you have questions, let me know. We'll talk to you soon. Bye.